This land was once home to indigenous tribes, including the Mingo and the Shawnee. They lived in balance and harmony with nature, and their waterways were clean, and there was abundant wildlife and abundant wild food plants. This land provided for all the needs of the people. Unfortunately, those now living on this beautiful land are faced with a continual threat from industrial development and industrial waste contaminating our land, air, and water. So I felt compelled to bring in the experts to help us understand the real threats we are facing here in our community. We will learn from Dr. Deziel, Assistant Professor of Epidemiology at Yale University, about her water quality research on drinking water supplies relating to fracking. Also, fracking wastewater, misleadingly called brine, and injection wells will be discussed by Dr. John Stolz, the director of the Center for Environmental Research and Education at Duquesne University. In the beginning, I decided to organize this meeting to complete my American Geophysical Union's Thriving Earth Exchange project. I am the community lead, and Dr. John Stolz is the scientific lead for the Barnesville project. We have been collaborating for 19 months now. AGU is an Earth and Space Science membership society of over 60,000 members who study everything from the center of the Earth to the surface of the sun and everything in between. AGU's Thriving Earth Exchange is to advance community solutions. The program helps scientists, community leaders, and sponsors work together to solve local challenges related to natural resources, climate change, and natural hazards. Dr. Stolz and I have been working with the Cambridge Thriving Earth Exchange project with Leatra Harper as the community lead and scientific lead Christopher Spees of Ohio Northern University. Together, our teams have conducted water sampling at Captina Creek and Cat's Run, downstream and upstream from the Exxon-owned XTO explosion site near Powhatan, Seneca Lake, Wills Creek, Cambridge Reservoir, and Slope Creek, directly downstream from the outflow of the reservoir. A special conference was hosted by participants in the Barnesville and Cambridge Thriving Earth Exchange projects at Salt Fork State Park Lodge. The purpose of the event was to inform residents about the health and liability issues associated with fracking. Originally, the plan was to host this event in Barnesville, but once I heard about the injection wells planned for Richland Township, I wanted to support the efforts of the concerned residents. So I decided to ask Dr. Stolz to share his expertise on injection wells. I'm very grateful to Ohio University Eastern for allowing us to gather here tonight.
And in my career, I've studied many different types of environmental pollutants or contaminants. And in the last 4 years, I've really focused on unconventional oil and gas operations, also known as hydraulic fracturing or fracking. And my research goal is depicted in this picture here. What I'm really seeking to understand is whether communities who live near unconventional oil and gas operations may be experiencing increased exposures to contaminants, such as in their drinking water, or experiencing health problems. And so what got me motivated to study this problem was just the sheer pace of expansion of this industry. You can see in this figure, it's showing the production volume of shale gas or natural gas from these deep rock reservoirs over time. And you can see just the very rapid growth in gas production over the last decade. And Ohio is one of the most prolific areas in the U.S. Producing this shale. So in Ohio here, we're over the Marcellus and Utica shales, so the green and the red slices of this wedge. This widespread expansion of the industry has led to 4 to 15 million Americans living within 1 mile of an unconventional oil and gas well, and about 9 million Americans having their drinking water source within 1 mile of an unconventional oil and gas well. And along with the oil and gas goes some of the water and chemicals that was pumped down originally. Also stored within the rock is brine, this kind of ancient salty water that's been interacting with the rock and therefore contains things like arsenic, lead, and radioactive compounds, which are all naturally occurring in the rock but have health concerns all the same. So all this millions of gallons of wastewater that are generated per well have to be managed at the surface properly. So this complex operation has many possible environmental health stressors, ranging from air emissions at the drill site to increased traffic and traffic accidents and noise. But today I'm going to be focusing on the issue of water quality and water contamination. So how could water get contaminated from this operation? There are several possible pathways. There could be activities at the surface, and in fact, a lot of the research suggests that this may be the primary way in which water is being impacted. So things like spills or leaks in the handling of water at the surface above ground can affect the drinking water. There may also be activities or things going on below the surface, below ground, such as deteriorating casing. So what brought me here to Ohio and to Belmont County? Well, I came here in 2016 and did a study called the Ohio Water and Air Quality Study. And I came because of that other graph I showed you. Ohio is one of the biggest producing areas in the country. And here in Belmont County, it's really quite a hot spot with all these black triangles indicating shale gas wells. Also, very importantly, to the type of work I do, where we're asking people to open up their homes to us to test their water, it's extremely important to have good relationships with the community. And I was able to establish relationships with people like Jill and Captina Conservancy and other community members who helped make this research possible, and I really appreciate that. So in that study, we went to 66 homes in Belmont County and analyzed the samples for a range of various water contaminants, mostly volatile organic compounds. And we also looked at how close people lived to unconventional oil and gas wells. And this is one of our water collectors, CJ, who is from Belmont County. So I'm going to show a little bit of data to tell you what we found in that first study. And so you can see from this graph that in general, the dark blue bars are higher than the lighter blue bars. And people who live closer to unconventional oil and gas wells tended to have, were more likely to have chemicals detected in their drinking water for some chemicals. And the stars here indicate that statistically this was a meaningful difference. But for these chemicals, we did see that people who lived closer tended to have higher levels of these chemicals in their drinking water. Again, though, the levels were all lower than what EPA would consider to be harmful. But we still saw that pattern. So the major takeaways from that first study that I did in 2016 were that homes located closer to unconventional oil and gas wells had higher detections and concentrations of several chemicals, but that the concentrations met current standards. This study did not tell us anything about the source of these chemicals. So many of these compounds that we're measuring have other sources in addition to the hydraulic fracturing process. Some may be naturally occurring even. But these findings did show some patterns that really underscored the need for more research to really try to understand what was going on here. So that leads me to the study that we're doing right now that brought me back here to Belmont County. We're conducting a new study called the Water Study, the Water and Energy Resources Study. And our goal is quite similar. It's to understand whether or not the unconventional oil and gas industry is impacting the quality and the chemistry of drinking water in both Pennsylvania and Ohio. We went to Pennsylvania last summer, and we're here in Ohio this summer.
According to your website that was updated in April, you have 223 active injection wells in the state. There are drilled or drilling at least 10 more and 12 permitted. Same number of volumes. So now you've got double the volume because you got 2 wells going. So now we're talking about at least 840,000 gallons per day, perhaps over 1.2 million per day. Now, how much volume is there in the average brine truck?
Yeah, exactly.
4,500 gallons. So you guys do the math. Lots of traffic, but anyway. So lastly, okay, why such the concern? If this were just salt water and you needed a place to put it, okay, I would not want to see these waves breaking over in Ocean City. Okay, and I'll tell you why. So over the years, I've had the opportunity to do a number of things. This is I can't tell you because it was part of a case I was involved with as an expert witness. But anyway, we were able to do air testing. This is a bank of condensate. You guys know about these tanks? You see them in all the wells, right? That's because they're injecting now upwards of 11 million gallons per well in the Utica in Ohio. Okay? And although a bunch of that stays down, a bunch of it comes back up. And initially it's called flowback because it has all the characteristics of what they put down the hole. But eventually, within the first 500 barrels, based on the research I've done personally, it turns into this brine with all sorts of goodies from the actual rock. And yes, the shales were ancient seas, or they were formed, more precisely, at the bottom of an ancient sea. But they also accumulated a lot of other stuff because of the fact that certain things like rocks or sediments opposed to seawater. So something like radium is attracted to the sea bottom as opposed to staying in solution. So anyway, what this is a Suma canister, and that basically allows you to test the air. And you can see the distance and everything. But we did this to 4 different banks of condensate tanks. And even though the wells were shut in, even though we were that distance, we were still able to, again, some of the chemicals that Nicole was showing you was showing up in the air in that canister, including benzene, chloroform, cyclohexane, and even a couple of banned CFCs, you know, the ozone-eating stuff, in measurable amounts. Okay, so in other words, this isn't like a puff. This is like, you know, if we went back, we would be sure that we would be able to test it again. Okay? And then, of course, and this is my photograph, this is from July of 2010. But again, these are these tanks that collect the produced water from the wells that are going off. And as I said, I like to call this the magic hose because when you look at the tanks, they are placarded, and I believe, because I've walked well pads in Ohio, they are placarded, produce water and crude oil. They're toxic and flammable. But miraculously, and this is what all these trucks are driving around here, it's suddenly residual waste. What happened to those organics? What happened to those flammable substances? It's just brine, okay? And this is, thanks to the kindness of strangers, I got a series of flowback from the Bakken. And why I'm showing this, the Bakken is in North Dakota, but it's from an oil well, and you can see each one of these represents 500 barrels. So this is the first one, and you can see it's kind of a creamy white, and you've got this brown crap in there. That's flowback, okay? But as you go and you let it incubate, and you know, that this is the next 500 barrels, that's the next 35,000 barrels. Anyway, eventually it looks like this. okay? And that's what you gotta get rid of. And you've got the Utica, which the reason why it's been so successful is because when oil was almost $100 a barrel, or close to, it was what you guys wanted, because you have mostly oil in Utica. You also have Marcellus, but that's gas, and and the other thing that you guys are after is the ethane. So anyway, that's another story. So again, what did I find there, and what's the message? Okay, so this is our analysis. Specific conductivity, water by itself does not conduct electricity, it's just H2O. But when you start putting things like sodium chloride, which is table salt, and a bunch of other stuff, it now becomes conducting. And so we use this measure in special equipment called a conductivity meter. And you can see the specific conductance is really high in this stuff. Okay, and that's because there's a lot of chloride. That's 96,000, so that's basically 96 grams per liter. Okay, and what's it, 4 liters in a gallon? Anyway, but the other thing is bromide, and why is bromide important? You don't find bromide in drinking water, and it's a good thing you don't, because bromide combines with chlorine in the final step of chlorinating your public drinking water to form those chloroforms and bromoforms that Nicole is measuring. And they cause cancer. And they are regulated by the EPA. And your drinking water authorities have to report every quarter, or at least measure, for trihalomethanes. And if they don't reach compliance 4 quarters in a row, which is how many? That's 1 year. Then they have to send you a notice saying that they're in violation. Road brining is also not a solution. Why? Because again, the residual materials as well as the radioactivity. And frankly, because they're using the same drilling techniques and the same chemicals for conventional wells now, I could show you a bunch of data that shows that conventional well brines are just as toxic or have the same constituents, more specifically, as the unconventional, because they're using the same chemicals to get as much gas out as possible. This is from a recent study that was done by Penn State. Okay, and then of course here's my data from Aqua Salina, thanks to a concerned citizen in Ohio who ordered it from a Lowe's and had it shipped to my house in Pittsburgh, because they don't sell it in Lowe's in Pittsburgh. But anyway, it's called Nature's Own, and of course the main ingredient is ancient seawater. This stuff is formation water. It's been sitting there for 400 million years plus. It's taken on all the constituents of the rock itself, including, your own ODNRs shown that some of the product had up to 2,500 picocuries of radium, and the drinking water standard is 5. And like everything else, there's no safe level of radioactivity, although I know there are people that will argue until they're blue in the face that a little radiation is good for you. But anyway, all these things that are in red are in non-compliance if it were to show up in your drinking water. So there's arsenic, there's chromium, there's high levels of iron, and you're supposed to directly put this on your sidewalk. And your ODNR used about 500,000 gallons of it on your roads last year. Okay? So again, it's not ancient seawater. And take a look at the bromide. So, where does the runoff go? It goes into your streams and your creeks and your rivers, and guess what? That's in many cases, where your municipal drinking water facility is getting their stuff. And look at that. Over 2.5 grams per liter of bromide in this product that you're supposed to use at 100%.
As John said, I'm an attorney with Fair Shake Environmental Legal Services, and I first just want to let you know a little bit about who we are. So we are a nonprofit law firm with offices in Akron, Ohio, and Pittsburgh, Pennsylvania. We work throughout both states, so throughout Ohio and throughout Pennsylvania. And about 40% of our docket has been work involving natural gas infrastructure in some way or another, just because that's who's walked in the door. Other things that we work on might involve septic problems or sewer issues or legacy coal issues. It could be all kinds of environmental concerns. So our basic design is just we serve modest means clients on environmental matters to try to make environmental justice something that is actually accessible for folks. And we've been doing that for 5 years now. So I was asked to speak here today, I think some to speak to the points that Dr. Stolz raised in terms of the limitations of the laws. And also to give you a rundown of how you might become involved in the process moving forward with these injection wells that are proposed for your area. So in terms of a rundown of the laws and what they do and do not do. So in the case of Ohio, while it is true that in general US EPA is who oversees the underground injection control program under the Safe Drinking Water Act. In Ohio, the Ohio Department of Natural Resources has primacy to administer that act.